so we left off in class the other day with the number line model, and remember we showed integer addition using a number line model. So that we, if we modeled that by maintaining the same direction and moving forward or backward depending on whether you had a positive or negative integer. And so for subtraction, you model that by turning around. And this example is a little bit more complicated to show, so I would strongly suggest that after you get through viewing this video that you go back to your textbook and on page 233 you look at their example. It's an actual school book page of where they use the number line model for subtraction of integers, okay? So then you have next the pattern model for subtraction, and this is based off of using inductive reasoning. And so you start with a known subtraction fact, like 3 minus 2, we know that equals 1. And so then we would just keep following the pattern. Well, 3 minus 3 then we know is 0. And so these are going down 1. So 3 minus 4 would have to equal negative 1. And 3 minus 5 then would have to equal negative 2, okay? We could also start and say 3 minus 2 equals 1, we know that. Then 3 minus 1 would have to equal 2. 3 minus 0 would have to equal 3. And so then when you had 3 minus a negative 1, because this pattern is that we're going up 1 here, then 3 minus negative 1 would have to equal a positive 4. Okay? We can use that missing addend approach. We use this missing addend approach when we studied subtraction of whole numbers. And so subtraction of integers, just like when we did subtraction of whole numbers, can be defined in terms of addition. So if we wanted to compute 3 minus 7, then we can think, okay, 7 plus what number would give us back this positive 3? And that would, of course, have to be negative 4. Okay, so our missing addend there would be negative 4, which would be the answer to our subtraction problem. Okay, and then we have a definition of subtraction of integers. Okay, for integers a and b, a minus b is the unique integer n such that a equals b plus n. Okay, and so if we go on to our subtraction using the opposite approach, this is really what mainly when you follow your rules for subtracting integers that you probably learned in school, this is really what the rules for subtracting integers was based off of. And subtracting an integer is the same as adding its opposite, okay? And so if you had all integers a and b, for all integers a and b, a minus b is equal to a plus the opposite of b, okay? And so we basically can take that and think of it as a rule, okay? So we would change our subtraction to addition, and then we would change the sign of the second number. Then all you have to do is go back and follow your rules for adding integers because you've changed it to an adding problem. So what do I mean? Well, if I have 3 minus 5, then that's really the same thing as 3 plus negative 5. And so signs are different, so I would subtract and keep the sign of the larger number, and so that would give me negative 2, okay? And so the original problem here, I'll write it above it, was really negative 4 minus negative 8. And so if I change my subtraction to addition and the sign of my second number, that's really negative 4 plus positive 8. So here I would follow my rules for addition. Signs are different, so I subtract and keep the sign of the higher number. So negative 4 minus negative 8 is really negative 4 plus positive 8, which gives me positive 4. Okay, so on the last page here we have some try these problems that are going to be very similar to your MyLabs Plus homework. And so if we start here with A, okay, and we're going to use the fact that A minus B is equal to A plus the opposite of B to compute each of the following. So 2 minus 8 is really 2 plus negative 8. And signs are different, so I subtract and keep the sign of the larger number. I get negative 6. Okay? So for B, I have 2 minus negative 8. And so again, I would change my subtraction to addition and the sign of my second number. So that's really 2 plus positive 8. And so signs are the same, they're both positive, so I add and keep the same sign, so that's really positive 10. Right, moving on to C here, I have negative 12 minus negative 5. So again, I'm going to change my subtraction to addition and the sign of my second number, so that's really plus a positive 5. And so signs are now different, so I subtract and keep the sign of the higher number. I get negative 7 there. Okay, D, I have negative 12 minus 5. Well, negative 12 minus 5, again, I'm going to change the subtraction to addition and this to a negative 5. And so now my signs are the same, so I'm going to add and keep the same sign. So I get negative 17 for my final answer there. Okay, so for the next section, write expressions equal to each of the following without parentheses. So for A here, I have negative, or the opposite of B minus C. And so what I do is I like to think of this as really an understood negative 1 in front of this parentheses. And I'm going to have to distribute and multiply this negative 1 times both of these terms. And so negative 1 times B is negative B. And negative 1 times negative C, well, a negative times a negative makes that positive. So that's really negative B plus C. Okay, so for B, you have A minus parentheses B plus C. And so that's really a negative 1 understood to be in front of that parentheses. And so I'm going to do my distributive property and multiply negative 1 times both of these terms. So I bring down this A, and negative 1 times B would be minus B, and negative 1 times C would be minus C. So A minus B minus C would be my final answer there. Okay, so for the next section, simplify each of the following as much as possible. So for A, we have 2 minus parentheses 5 minus x. So this is a negative 1 understood to be in front of this parentheses. And so again, I'm going to do my distributive property and multiply negative 1 times both of these terms. So I bring down the 2, and negative 1 times 5 is negative 5. Negative 1 times negative x is positive x, or plus x here. And I need to combine my like terms here in the front to simplify this as much as possible. So 2 minus 5, remember, is the same thing as 2 plus a negative 5. Signs are different, so I'm going to subtract and keep the sign of the higher number. So negative 3 plus x would be my final answer. Okay, moving on to B. I have 5 minus parentheses x minus 3. And so we have negative 1 there in front of that parentheses. I'm going to distribute that negative 1 times both of these terms. And so I'm going to bring down that 5. And negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. And so now I still need to combine my like terms of 5 plus 3, which gives me 8 minus x. Final answer. Okay, moving on to C. I have negative times parentheses x minus y minus y. And so again, this is understood to be a negative 1 in front of this parentheses. So I'm going to distribute this negative 1 times both of these terms. Negative 1 times x is negative x. Negative 1 times negative y makes that positive y, so plus y minus the y on the end. Well, y minus y is 0, and so I'm just left with negative x here as my final answer. Okay, so for D, I have 3 minus parentheses 2 minus 4x. And so again, there's a negative 1 understood to be in front of that parentheses, and I'm going to do my distributive property and multiply negative 1 times both of these terms. So I'm going to bring down the 3 in front. Negative 1 times 2 is negative 2, so minus 2 here. Negative 1 times negative 4x, a negative times a negative makes that positive, so plus 4x here. I combine my like terms. 3 minus 2 would be positive 1 plus 4x for my final answer. Okay, and finally E, I have x minus, parentheses, negative x minus y. And so there's a negative 1 understood to be in front of that parentheses. So I'm going to distribute that negative 1 times both of these terms. So I bring down this x in the front. Negative 1 times negative x. Well, a negative times a negative is positive, so plus x. And negative 1 times negative y is how we're going to think of this. Well, negative times negative makes that positive, or plus y. I need to combine my two terms here in the front, so that's really 1x plus 1x, which gives me 2x plus y for my final answer. Okay, then we move to order of operations, and remember that subtraction we learned when we were dealing with whole numbers, and this applies for integers as well, is neither commutative nor associative. So the commutative nor the associative property hold for subtraction of integers. And so we really need to know an agreed upon order then that we would have to work an expression like 3 minus 15 minus 8, okay? And so mathematicians agree that we should work this in order from left to right. In other words, we would do 3 minus 15, then minus the 8, okay? So we're going to try these. And we're going to start with A. So 2 minus 5 minus 5. And so I would start here with 2 minus 5. Well, 2 minus 5, remember, is the same thing as 2 plus negative 5. And so I would subtract because signs are different and keep the sign of the higher number. So I get negative 3 minus the 5. Okay, well, negative 3 minus 5 is really negative 3 plus negative 5. And so now signs are the same, so I add and keep the same sign. That gives me negative 8 for my final answer on A. Okay? On B, I have 3 minus 7 plus 3. So if we go in order from left to right, 3 minus 7, remember, is really 3 plus negative 7. And so signs are different. I will subtract and keep the sign of the higher number. So I get negative 4 plus 3. And now signs are different, so I'm going to subtract and keep the sign of the higher number here. So that would give me negative 1 as my final answer. Okay, so for C, I have 3 minus, parentheses, 7 minus 3. Okay, well, I'm going to go ahead and work inside this parentheses first because I can subtract 7 minus 3 and get 4. And that's order of operations says that we should work inside of our grouping symbols first here. So that would really be 3 minus 4. Well, 3 minus 4 is really 3 plus negative 4. And so now signs are different, so I'm going to subtract and keep the sign of the higher number. That gives me negative 1 for my final answer for C. Okay, so if we move on to D, okay, so for D here, we have negative 2 plus, parentheses, 3 minus 10. And again, I'll work inside my parentheses. So 3 minus 10 is really 3 plus negative 10. And so signs are different, so I will subtract and keep the sign of the higher number. That gives me negative 7. So this is really negative 2 plus negative 7. Okay, well now I'm adding and signs are the same, so I add and keep the same sign. So I get negative 9 for my final answer. Okay, so for E, I'm going to work inside my bracket first. Following order of operations, I work inside of my bracket first. And so 8 minus negative 5 is really 8 plus positive 5. So signs are the same. I'm adding. Signs are the same. I'll add and keep the same sign. So positive 13 minus 10. Well, 13 minus 10 we know is 3. Okay. And F, the last one on this set, we have negative 2 minus 7 plus 10. And so we'll work this in order from left to right. And negative 2 minus 7, remember, is really negative 2 plus negative 7. So I'm adding, and signs are the same, so I add and keep the same sign. I get negative 9 plus 10. I'm adding, signs are different, So I will subtract to keep the sign of the higher number. I get positive 1 as my final answer on F. Okay? And so for the last one here on G, it says on January 1st, Jane's bank balance was $300. During the month, she wrote checks for $45, $55, $165, $35, and $100, and she made deposits of $75, $25, and $400. If a check is represented by a negative integer and a deposit by a positive integer, express Jane's transactions as a sum of positive and negative integers. What was the balance in Jane's account at the end of the month? Okay, so it tells us that she started out with a positive 300 for her balance at the beginning of the month, okay? And she wrote checks for 45, 55, 165, 35, and 100. So those would all be negative. So plus negative 45, plus negative 55, plus negative 165, plus negative 35, plus negative 100. Okay? But she made deposits, so that would be plus positive. So plus 75, plus 25, and plus 400. So what I will do to get the total and her balance and her account at the end of the month is I'm going to take and add my positive numbers together first. So 300, 75, 25, and 400 would give me 800 for my positive amount. Then I'm going to add my negative integers, my checks together, okay? And so if I use my technique of combining nice numbers to get nice totals here, negative 165 and negative 35 is negative 200. And negative 45 and negative 55 would be another negative 100, so I'm up to negative 300. Plus this last negative 100 here would be negative 400. So that's really plus a negative 400 for her checks. And so signs are different. I subtract and keep the sign of the higher number. So she had a positive balance of $400 in her account.